Okay, so kind of wanted to go over this really quick, and this is my Rev 2 for my lab power supply that I've been working on, it seems like forever, but I want to improve the efficiency, and I think I may have talked about this before, but see, so let's just go down here to a piece of paper. So imagine we have 24 volts going in to our linear regulator element, which is the LT3080. But imagine we have 24 volts going in, and we want to regulate it down to, I mean, even like 0.2 volts or 200 millivolts. That's a quite big deal of difference there. So you're going to be dissipating all that extra voltage into heat. And depending on what current it's at, that could be like I said, that could be a fair well deal of heat there. So for one, you would have to have a pretty big heat sink, and for two, it's just a problem because it's going to heat up the linear regulator. It's going to change its regulation characteristics and just all sorts of stuff that we do not want to deal with. But what we can do is have something here called a tracking pre-regulator, and this is a switching regulator, which is a lot more efficient than a linear one. And you might ask, well, why not just use a switching regulator as our main regulator element? Well, the answer to that is a switching regulator has a switching frequency inherently imposed into its output. So this one that I've picked is from Diodes Incorporated. It's a PAM 242. Has a switching frequency of just a couple kilohertz. Let's see what I've done here so I can digitally control it. Is I've put a digital potentiometer here into the feedback pin of this regulator. So how this works, you change the ratio of resistors here, and it will change the output. And this is a boost buck regulator, so you can boost the voltage up and then knock it back down. So the idea here is to feed in 5 volts from an input, DC 5 volts, and then it'll come here, and if I want to go up to 24 volts, I will change the resistance via the I2C bus of this digital potentiometer, and all is good. Well, this has just been kind of conceptualized, and I didn't really want to get a board made just to kind of fail. So what I have done, I remembered I have ltspice on my computer. This is a circuit simulation program, and they don't have that exact part there, that switching regulator I've used, but this is a very similar one, the LT1935. And as we see, I have essentially the same thing, but here is this resistor is acting as that digital potentiometer. So I can adjust this, and we can see how the circuit will behave. So let's go ahead and put it at its extreme value of 5K and see how this circuit behaves. Put that there, and we'll go up to run. Probe the output here. Let me see. So the higher resistance there is going to mean a lower output. So we see here we are roughly about 9.85 or 8.9 volts thereabouts. So that's a lot better than what we were doing. So now let's lower this resistance here to the lowest extreme, which I measured of about 100 ohms, let's just say roughly. So now let's halt our simulation. Let's run our simulation. And now let's probe the output. And it shot way up. Its transients are kind of crazy here. Oh, I know why. Because I have a pretty decent sized load. Hold on, my bad. I was playing around with this, and I put like kind of a big load on this. Let's just leave this at 6 milliamps for right now. And okay, let's redo that. Probe the output there. Zoom this fit screen. You see our transient, we are getting up to about 24 volts there. About 20, that's probably about 23. Yeah, about 23 volts. So we see this is actually working pretty decent. And as far as that load situation, in actuality, it probably is going to be just fine with it pulling current through there, because the IC that I've chosen can handle up to 3 amps, so I think we ought to be fine. But I'll probably have to play around with these inductor sizes, and then of course I'll have to deal with some kind of filter to filter out that nasty switching frequency. But on its way to the linear regulator, it should be fine. Here is the main regulation stage. But yeah, kind of just wanted to go over that real quick and kind of display the usefulness of spice simulators, or a circuit simulator, if you will. So I will talk to you later.